Good evening, everybody. Today's video will be on looking at 4 different questions pertaining to transfer of thermal energy. Okay, we'll look at how we analyze the questions to see how conduction, convection, or radiations fit into the questions, and how we decipher which methods of heat transfer is actually the most appropriate one. Before I go to the questions, I'd like to highlight the clues or the key terms that I mentioned in the last video, which is what you see on the screen now. Okay, in the last video I highlighted some of the key terms or clues that the questions might be using. What are the clues to look out for them, and what are the respective heat process they mentioned, they referred to it. Okay, so before we start the questions on that, I want to highlight to students to actually run through that video if you have not done so. We have to look at the clue, familiarize yourself with the clues and the possible type of questions and the possible heat transfer method that is tagged along to the clues. Okay, so for conductions, okay, convection and radiation, they have their respective clues. Okay, now we'll look at the questions and we see how we can use the clues actually to solve the questions here. Okay, for the question 1 we have is about woolen clothing, effectively keeping us warm, okay, for various reasons. Okay, before we proceed at looking at the questions, I want to highlight a few things here. Based on the questions, what is given is yes, it's about clothing. What clothing is the question talking about? Okay, in this question here, the clothing that is in discussion here is the woolen clothing. So the woolen clothing, the only thing that we don't know the color, but we know the material woolen. Okay, we know that this is a type of medium, okay, a type of material. Okay, the material type. Okay, we know this is the material, and we know that sizes, M size, L size for clothing is not mentioned here. So sizes, surface area, all these are not related. So if you look at the question here, the question actually focuses primarily on the clothing itself, the type of clothing used, type of material used, which is woolen. So if you look back to the clues and key terms that I highlighted in the previous video, you will find that, okay, the type of material that we actually refer to is actually commonly used for clues that to highlight a certain process, and that process is actually known as conduction. Okay, so this is what I mean by you sieve out important clues from the questions to decipher what are the possible modes of heat transfer that the question is targeted on. So when you talk about material, the mode of conduction and mode of heat transfer that we are looking for is conduction. Okay, so we will look for the options that actually relates directly to conductions, and that is most likely your answer for these particular questions. So with this in mind, you will find that C I can actually narrow down. I can actually kick it out because it's about radiation. After that, wool can retain high temperature. There's no indication of it. Okay, and from the clues we know that high temperature actually relates to radiations. But the question that we analyze that is pertaining to conduction. So D is also out. Okay, and from when you have knocked out C and D, you only left with A and B. B you will know is wrong because by convection, but the question we are looking at is conduction. Okay, and radiation, there's no mention of size, color, texture, or even the temperature of the material itself. So radiation most likely will not be in the question here. Okay, and with B, C, D out of the way, most likely you will know the answer is actually A. Okay, and how do we know it's A? Because for A, it mentioned about air. And it is true that there's actually layers of air being trapped inside clothing. And we also know one thing about air. Air is what we know as a common thing that we always use, and that this being common thing is that air is actually a bad conductor. Okay, so these are certain things that we call common understanding or common knowledge that we need to know. So we know that air is a bad conductor, and that's why it's actually used, okay, in between the layers as to keep us warm. It acts as a good insulator. So this is what I mean by you look at the question, analyze the question to sieve out important clues to tell you to relate to the necessary mode of heat transfer. For the second question that we're looking at, you'll find that the question we are talking about is hot water. Of course, hot water here relates to high temperature. Okay, so if you look at high temperature, it's possible that we are looking at hot stuff, and it's water, but in nature, so most likely conduct, convect, radiation, they are involved. So but you look at hot water, most of the time the processes that we are looking for is actually convection. Of course, high temperature, it also could mean radiations. Okay, so if you look at these two methods, what are the possible key method that we're looking at is you have to look out for the second clue. Based on the question, the second clue that's given is placed at the bottom. Okay, in this case, we have what we means by locations. Okay, among the two methods, convection and radiation, there's only one mode of heat transfer that actually insists on certain location, and that particular mode is convection. Because for convection current to occur, you must have a certain directions in mind, whereby hot water can actually be raised or can float, raise up because of less dense, and the cold water can actually sink down because of denser in density. So there's this up and down cycle that we're looking for. Up and down actually refer to the location. Okay, so if you look at it, you'll find in this question, from the question itself, the question is most likely, from the clue I can actually infer that most likely the question is actually targeted at convection current. So with that in mind, you'll find that A is out, okay, and you'll find that D is out also, and also C automatically is out because it's targeted at radiations. And from the question, you actually analyze that there is a high percentage or high chance that the question is about convection. Okay, and true enough, there's B, which is one choice, is talk about convection, whereby the hot water will be able to rise and eventually cold water can sink, and it leads to the formation of convection current. And that's how you actually narrow down on my answer to be B, convection, because of the clues given in the question here. So students, we need to make sure that we actually have a habit of analyzing questions using the clues to our advantage, rather than just 100% guessing or 100% looking at analyzing the questions from scratch. Okay, we need to use our clue to our advantage. The third question we have here is we talk about hot water pipe. Okay, heat up the energy in air. So when we talk about air, we talk about fluid. When we talk about air, most of the time we are looking for air is actually two things. It could be conduction, because air is a bad conductor, or it could be air pertaining to air being able to become hot air, whereby it's less dense, it rise up, cold air, you will sink down. So there's up and down, there's a convection current occurring. So air could be actually targeted at convection current. Okay, so which is more towards the question we have analyzed further. Okay, then after that, you'll find that the second clue that's given to you is hot water pipe. So hot water here refer to high temp. Okay, but when we mention hot water pipes, I would say the more focus will be on the pipe itself. So pipe here we're looking at is the material itself. Okay, so if you look at the material itself, and if you refer to the clues that I actually documented in the previous video, or the one that I showed you in the beginning, you'll find that material is actually targeted at conduction. The process that we're looking for is conduction. Okay, so you'll find that from the clue that's given to us is that heat transfer through the metal pipes is through conduction. So you'll find that A and B is possible the answer. So you actually knock out C and D already. Okay, so A and B is the possible answer. And we look at air, pertaining to air, through air. So you have a pipe, okay, you have the water going through, okay, heat transfer from the water to the pipe. This we have settled is through conduction. How about from the pipe through the air here? Okay, through the air here in conductions here, when we talk about air, most likely we are looking at for the main mode of heat transfer. When we talk about air, is actually convection, because hot rise, cold sink, which means this mode of method is actually much faster than conduction, which air happens to be a gas, and the only mode of conduction that we are looking for is actually molecular vibrations. So if you look at molecular vibration for conductions and convection, you'll find that convection current actually occur at a faster rate. Okay, because hot will rise, cold will sink. So this action is actually faster if you look as compared to the collision sections. So you'll find that actually through air, the main mode of heat transfer, even though I have both, okay, but because of efficiency, because of the nature of the material itself, the gas, you'll find that main mode of heat transfer will still be primarily convections. So if bearing this in mind, you'll find that the only answer that suits all this is actually A. Okay, so I repeat again, the idea about this question is to this worksheet is actually to run through or to give a simple warm-up for students, okay, for yourself, to actually use the clues that are documented or the clues that you have sieved out to analyze the questions, and from there decipher the necessary or the most logical heat transfer methods that the question is asking for. Same thing as before, building in hot countries, okay, are painted white. So we talk about building. Building, we will not know what building is. Is it a building made of wood or concrete? So there is not enough information. So it could be like 90% concrete, because most of the time modernized buildings. But we're not too sure, so there's no enough clue. So we can't really say buildings is actually telling us to use material. So it's hard to decipher. Hot. Okay, we do know that if this is the building, the clues here, hot, refer to outside is hot. The environmental is hot. The body here is actually cold. So the transfer of thermal energy will be from outside to inside. Okay, so that's what this clue is actually trying to tell us. Painted white. White, okay, I would say this is a very straightforward clue. White here will refer to actually color. And among all the three mode of method that we're looking for, the mode or method that we're looking for is actually radiations. Okay, but remember, under radiation here, there's two things that you must decide. First is radiation, the mode, and second is you must decide on the nature of the object. Whether is it acting as an absorber or is it acting as an emitter. Okay, so this is the one that students you have to actually sieve out. So the first cut to sieving out is to arrive at radiation, the choice between conduct, convect, and radiations. So once you have made the choice, you narrow it down to radiations because of the clue, color. Then the next chore that you have is actually to narrow down on the correct modes. Is it the object acting as an absorber or acting as a emitter? And same as before, remember there are conditions for absorber and emitter. If you are having an absorber, you'll find that, okay, your temperature versus the environment temperature, okay, is always this check, okay, to check all this. If you are absorber, your body temperature must be lower than the environment. So I must be colder, the environment must be hotter, so that you have a heat transfer whereby you have energy from outside to inside. And what's the process? By absorption. And similarly, the reverse will happen. If you are an emitter, means if you want to emit energy, one of the criteria that you must have is that your body must be hotter than the outside. Right? As a result, you will actually keep giving out heat. So that's why it's one of the main conditions that you are acting as an emitter. So from the hot clue here, you'll find that outside is hot, your body is actually cold. So the energy transfer will actually from outside to inside, meaning your building here will be actually adding as a absorber. Okay, so that's why if you're looking at radiations, you find that actually all the four choices are about radiation. So based on the clues given, the second clue that I'm looking out for is that I'm targeting absorption. So it's only A or B only. C and D I can knock out straight away because they deal with emissions or emitters. Okay, so white, remember white is a bad absorber and a bad radiator. So if I targeted at absorber, so my white will automatically give me a bad absorber. So that's why I will actually choose my option to be B. White actually make heat absorption slower. As a result, my building is actually maintained at a lower temperature. Okay, so this is what we mean by absorption. Okay, now for these four questions, I will not say they are difficult. It's like I mentioned before, it's a primary task actually to let you guys actually warm up, to have the habits of analyzing the question using the clues, looking for clues to actually to deduce the correct mode of heat transfer. Okay, I hope this short 5 questions, a short video actually will be a good starter for you, a good application for it. Okay, there will be one more video on the applications. Okay, so in the next video, I will be looking at other questions. So stay tuned. Okay, so read through. Okay, see you.